Hi students, so let us start our exercise 2.2 on the definition of relations. Clear? So already we have solved one of the example on relations. So further two examples are very simple, you can understand on yourself. I will directly go to exercise 2.2. Okay. So here in the first question, let A equal to be the set of 1, 2, 3 so on to 14. Define relation R from A to A. Define relation R from A to A by R equal to set of order pairs x comma y such that 3x minus y equal to 0 where x comma y belongs to A. Write domain, codomain and range. Clear? So here they have given the set A. Without set they can't define relation. So that's why they have given the set A which contain 1 to 14 natural numbers, and R is defined as set of order pairs x comma y such that 3x minus y equal to 0. So as you all know, first we have to write relation R. Clear? So x comma y. If I take x value as 1, see here, if I take x value as 1, 3 into 1 will be what? 3. 3 minus which term will be equal to 0? 3 minus 3 will be equal to 0. So that's why if x is 1, y is 3. Clear? Now I will take x value as 2 because 1 is over. Now I will take x value as 2. If I take 2 here, 3 into 2, 6. 6 minus which term will be equal to 0? 6 minus 6 will be equal to 0. So that's why y term is 6. Clear? If I take 3, 3 into 3 is 9. 9 minus 9 will be 0. So y term is 9. Clear? If I take 4, see, 3 into 4 is 12. 12 minus 12 will be 0. So that's why y term is 12. Suppose if I take 5, x value as 5, what you are going to get? 3 into 5, 15. 15 minus 15 is going to be 0. But here there is no 15. Your set ends at 14. So that's why 15 is not in your set. So that's why I can't take 5. Clear? So therefore this is your relation R. Clear? So from this we shall write domain, codomain and range. Okay. First domain. What are the domain set? The collection of the elements from the order pairs at first position. Here you have 1 at the first position. Here you have 2 at the first position. Here you have 3. Here you have 4. So that's why domain will be 1, 2, 3, 4. Clear? Codomain is very simple. You know the definition of codomain, that is the set itself. Here the A itself is codomain because if they give two sets A and B, B will be the codomain. But here they have not given B, so they are defining the relation from A to A itself. That's why A is going to be domain and A is going to be codomain. So that is 1, 2, 3, so on to 14. Clear? Now let us go for range. So range will be equal to the collection of second elements, that is 3, 6, 9 and 12. 3, 6, 9 and 12 will be the range. Clear? So domain is 1, 2, 3, 4. Codomain is 1 to 14 and the range is 3, 6, 9, 12. Here very important is writing this R. Are you getting my point? If you write this R carefully, then definitely you are going to get the correct answers for domain, codomain and range. If you miss writing R, or if you can't write this relation R in this form, then definitely you can't get domain, codomain and range. So here please concentrate on writing this R. If you write this R, then everything is simple. If you don't write this R, you are not going to get anything. So that's why please make sure that whenever you are writing a relation R, construction of your order pairs x comma y, so that should be very much clear. Okay, that you must understand carefully. Then only you can write the correct answers. Let us go for the next question. Okay students, now let us see the second question, that is define a relation R on the set n of natural numbers defined by R equal to set of order pairs x comma y such that y equal to x plus 5 comma x is natural number lesser than 4, x comma y belongs to n. Depict the relationship using roster form. Already in the first problem we have written the problem in the roster form only. Again they are asking the same thing, no problem. Write the domain and range. Clear? So in the first problem also we have written the R, that is nothing but the roster form. Here also they are asking to write them it in the roster form, then domain and range. No problem, we can write it. Okay. So here order pair x comma y equal to x plus 5, x is natural number lesser than 4, x is natural number lesser than 4 and x comma y must be in natural numbers. No problem. First let us write R. Here you have to understand. See, x is what? X is natural number less than 4. X is natural number less than 4 means for x I can take 1 which is lesser than 4 and it is natural. If I take x as 1, y will be how much? 6. Next I can take x as 2, y will be how much? 7. Because here if I put x equal to 2, 2 plus 5 is 7. If I take x as 3, 3 plus 5 will be what? 8. Clear? If I take x as 4, here y will be how much? 9. Okay. So here ends your relation. X value you can't take more than 4 because there is a condition for x, that is x should be natural number lesser than 4. So lesser than 4 means you can't take 4 also. Clear? Lesser than or equal to means you can take 4. Lesser than 4 means you can't take 4 also, because you have to choose the numbers lesser than 4, not lesser than or equal to. If they say lesser than or equal to, you can take 4. So here they have told only lesser than 4. So that's why here it ends for 3. So 1 comma 6, 2 comma 7, 3 comma 8. I can't take 4 because they have condition for x, that is x should be lesser than 4. So now this is your nothing but roster form. Depict the roster form means this is your roster form. From this domain, domain is what? Very simple. Collection of first elements 1, 2, 3. Next range. Range is what? Collection of second elements, that is 6, 7, 8. Clear? So this is the roster form and this is domain and range. Clear? So be very careful while writing R because these conditions are very important. As the conditions are given, on that conditions you have to solve the problem. So that's why please don't make any mistakes while writing this R. Clear? So this was also a very simple problem. I think you are getting my problems. So I will go for the next one. Friends, see the third question, that is A equal to set of 1, 2, 3, 5 and B equal to set of 4, 6, 9. Define a relation from A to B by R equal to set of order pairs x comma y such that the difference between x and y is odd. The difference between x and y is odd. X belongs to A, y belongs to B. Write the R in roster form. No problem. Okay. So they have given the set A and the set B, and the condition for the R is the difference between X and Y is odd. The difference between X and Y is odd. X belongs to A, comma Y belongs to B. Okay. See here, R equal to set of X belongs to what? A. From A I will choose 1. Now from B you have to choose the element. Clear? So while choosing the element from B, see the condition of R. The difference between X and Y is odd. The difference between X and Y is odd. That means here you have to choose the number from B such that their difference is odd. I can write 4 because 1 minus 4 is minus 3, or 4 minus 1 is 3. So 3 is odd number, no problem. Again for 1, what you can choose? For 1, can you choose 6? You can choose 6 because the difference is 5. So therefore 1 comma 6 also I can write, because the difference will be 5 and 5 is odd number. Next, for 1, can you choose 9? No, you can't choose 9 because the difference between 1 and 9 will be 8, where 8 is not an odd number. So that's why 1 is over. Now go for 2. For 2, can I choose 4? No, because the difference will be 2. 2 is not odd number. Can I choose 6? No, because the difference between 2 and 6 is 4. 4 is even number, so I can't take 6. Can I choose 9? I can choose 9 because the difference is 7. So 7 is odd number. Clear? So here the relation is according to the condition given in the definition of R. Clear? So that's why we have to choose like that. Next, go for 3. For 3, can I choose 4? Yes, I can choose 4 because the difference is 1 and it is odd. Again for 3, can I choose 6? I can choose 6 because the difference is 3. 3 is odd. For 3, again can I choose 9? No, I can't choose 9 because the difference is 6. Therefore 6 is even number. So now go for 5. For 5, I can choose 4 because the difference is 1. For 5, I can choose 6 because the difference is 1. For 5, I can't choose 9 because the difference will be 4. 4 is even number. Clear? So this much is your relation R, which we have written in roster form. Here they have not asked domain, codomain and range. No problem. So try to write domain, codomain and range as homework. It is not in question, but you take an homework that write domain, codomain and range. Right? Domain, codomain and range of third question. It is not there in your textbook, it is not there in your question, but you try to write, because if you know the knowledge, you can write domain, codomain and range. If you have understood the classes, you can write domain, codomain and range. And there is no chance of making a copy because it's not in any textbook or it's not in any solutions of your NCERT. So that's why you take it as a homework and try to write domain, codomain and range. Clear? If you write these things as correctly, definitely you are good with this particular topic. Clear? Okay, now I will go for the next problem. Okay students, so now let us go for the fourth question. A very tricky question. Here they have given the arrow diagram. From this arrow diagram they are asking should write in a set builder form. That means this relation has to be written in the set builder form, roster form and write its domain and range. Here the arrow diagram is given. From this arrow diagram you have to write the relationship between P and Q in set builder form, roster form and its domain and range. Clear? Okay. For this, first let us write the two sets. What are the two sets? P equal to 5, 6, 7 and Q is equal to set of 3, 4 and 5. Clear? Now I will define relation, because without sets we can't define relation. That's why first I have written the sets. Now I will write the first question in set builder form. R is equal to, see in the previous questions they have given the question in set builder form and they have asked it in roster form. So the set builder form means you should create a definition. You should create a definition to this relationship. So see here, how can we write it? What I will do, I will construct an order pair x comma y such that order pair x comma y such that y equal to x minus 2, y equal to x minus 2, comma x belongs to p, comma y belongs to q. X belongs to p, y belongs to q. Because p and q are already given sets, no problem. So here you are constructing a R, that means you are constructing a relation in set builder form. See, x comma y, I have written the order pairs such that y is equal to what? Y is equal to x minus 2. That means the elements of x are from P set, that is 5, 6, 7. Clear? So if I put 5, 6, 7, I should get the terms of Q, that is y. Clear? Y belongs to Q. Let us check in roster form. In roster form you get the correct answer, then there is no question of getting confused. So y is from Q, x is from P. See here, x belongs to P, y belongs to Q, no problem. So I will write 5 here. So 5 minus 2 is how much? 3. So y, it is from Q, so that is 3, no problem. Now I will go for 6. I will take x value as 6. 6 minus 2 is how much? 4. So if x is 6, y is 4. It is also not getting with any problems. 7. 7 minus 2 is how much? 5. So 7 comma 5. See, it is in roster form. 5, 6, 7 are in the set P. 3, 4, 5 are in the Q. Clear? So in this way you must be perfect in writing both set builder form and in roster form. Clear? This is called roster form. The definition way is called as roster form. Sorry, set builder form. And this particular thing is called roster form. Clear? The first thing is called as set builder form, where you define with the definition. This is called roster form, where you make the list of order pairs. Clear? Okay. Now I will write domain. So domain is collection of first elements 5, 6, 7. Next I will write range. That is the collection of second elements. That is 3, 4, 5. So this is your 3, 4, 5. Clear? So domain and range. So very simple question, but you must know the particular things in detail. Then only you can write this type of questions. Otherwise you will get more and more confuses. Sorry. Clear? So that's why for that particular reason, if you know the particular things very clearly, here there will be no any confusions to write or to solve this type of problems. Clear? Okay, in the next class we shall continue with problem number 5. Okay.